Hello friends, welcome to my channel. In this video I will cover industrial engineering. Forget linear programming I will cover. Father of linear programming is George B. Dantzig. Then linear programming is used for optimization of our limited resources when there are several number of alternative solutions possible for the problem. Here requirements of linear programming is objective function in terms of maximization or minimization, and constraints or conditions or restrictions. One more thing you have to remember, this is also linear, and constraints or restrictions, these are also linear and non-negative. Here in this term they will give maximization z equal to c1 x1 plus c2 x2 like this to cn xn, linear and non-negative. Then conditions and or restrictions or constraints they will give a11 x1 plus a12 x2 like this, an xn less than equal to b1, less than or greater than equal to term, greater than equal to term you have to change. Then x1 x2 xn all are greater than 0 up to xn, and here c and b and a, these terms, these are constants, and ax terms, these are the variable terms. Here this type of questions they will ask. A company produces two products A and B whose profit is Rs 60 and Rs 60, Rs 70 per unit respectively. A requires 10 hours processing time on machine P and 6 hours on Q and 5 hours on R, where B requires 7.5 hours on P and 9 hours on Q and 13 hours on R. Weekly availability of machine hours for three machines PQR are respectively 75 hours and 54 hours, 65 hours. Find the optimum product mix to maximize the profit. So our objective function is Z max. We have to calculate maximum profit. First we will write in tabular forms. One side products with variables x1 and x2. Then other side maximum hours. In columns machine hours maximum available, PQR, and profit we will write. So for x1 in the given question, product for product A, in P machine it's taking 10 hours and Q it's 6 hours, 10 hours, then in Q it's 6 hours and R it's 5 hours. Then for B requires 7.5 hours on P machine, and on Q machine it requires 9 hours, and R it requires 13 hours. Then weekly availability of machine hours PQR respectively, it's 75 hours and Q it's 54 hours and R it's 65 hours, and profit is in A it's Rs 60 and in B it's Rs 70. So in table form we wrote this one. So from here we can write in linear form also. Then step by step we will do. Number of units to be produced per week for the product A, B. We wrote in x1 and x2 term. x1 and x2 are decision variables, and x1 and x2 both are greater than 0. Already discussed, it should be non-negative. Then objective function, we can write it as Z max equal to 60 x1 plus 70 x2. Here 60 in x1 and 70 in x2. 60x1 plus 70x2. We got our objective function or maximization of Z max. And for machine P, we can write it as, for P machine, it's from first column we can write it as 10x1 plus 75x2 is less than equal to 75. Then like this, from second column we can write 6x1 plus 9x2 is less than 52. And from third column we can write 5x1 plus 13x2 plus 65. It should less than 65. So 3 equations we got. So again I am writing them. For machine Q it's equation 2. Then for machine R it's equation 3. From equation 1 we can rewrite it as x1 divided by 75 by 10 plus x2 divided by 75 divided by 7.5 is less than equal to 1. So from here x1 by 7.5 plus x2 divided by it's 10, it's less than equal to 1. Then for Q we can rewrite it as x1 by 54 divided by 6 plus x2 divided by 54 divided by 9 less than equal to 1. So x1 divided by 9 plus x2 divided by 6 is less than equal to 1. And for from third equation we can rewrite it as x1 divided by 65 divided by 5 plus x2 divided by 65 by 13 less than equal to 1. So from here we will get x1 by 13 plus x2 divided by 5 less than equal to 1. So we got our coordinates. You can write it as equation A, here B, then this one as C. For equation A, x1 coordinate is 7.5 and x2 coordinate is 10. And for equation B, x1 is 9 and x2 is 6. And for equation C, x1 is 13 and x2 is 5. Then we can write our graph. So we will plot our graph. From equation A, x1 coordinate is 7.5. Let this side it's x1 and this side x2. So x1 is 7.5. So x1 is here, then x2 is at 10. Both are less than equal to 1. So here arrow will go towards 1. So arrow direction it's towards 0. Not towards 1, towards 0. Say 0. Then x1 is 9 from B. This represents A, equation A. For equation B, x1 is at 9 and x2 as 6. Both are less than equal to 1. So again arrow direction towards 0. This represents B. Then for C, coordinates are 13, x1 is 13 and x2 is at 5. So join them, you will get your feasible region. This is from C. So our feasible region is, we will mark them A, B, this is A point, here B point, then C point, then here D point. A, B, C, D, and here already O point. Our feasible region is O, A, B, C, D. Our objective function is z max equal to 60x1 plus 70x2. So at a point we will check z equal to a point 0 and 5, x1 is 0 and x2 is 5. So 60 into 0 plus 70 into 5, you will get 350 at a point. Then at B point, coordinates are 3.54 and 3.62. So 60 into 3.54 plus 70 into 3.63, you will get 466.5. Then at point C, z at C, coordinates are 6 and 2. So 60 into 6 plus 70 into 2, you will get 500 at C point. Then at D point also you have to calculate z at D point. Coordinates are 7.5 and 0. So only 60 into 7.5. So 60 into 7.5 and 70 into 0. So here you will get 450. So maximum is at C point, this one. You are getting 500. So maximum profit at C. This is your answer. They will ask in option A, B, C, D. They will give at A point or B point. So maximum profit value only you have to give. They will give in options 350, 500, 450, 400, like this they will give the options, and your option will become 500. This is your answer. This is the end of this video. Thank you friends. Thank you for watching my video. Thank you.